Problem number 3. Find the critical points of each function, this function here, and list them as ordered pairs. Don't worry what type of critical point they may be. Don't worry whether it's a maximum, minimum, or a point of inflection. Now when we have this graph, what's happening is, since it's an x cubed, I know it's coming in, it's hitting, it's going back up, and it's doing that number. Well, I'm wondering how can I find this guy right here, which looks like, oh, it's then going back up, so that's a minimum, and then it starts going back down, so this is like a maximum right there. Well, notice that the tangent line right here has to have a slope of 0, and up here it has to have a slope of 0. The tangent line has to have a slope of 0 there. Well, the derivative tells us the slope. We can find the slope of the tangent line. That's what the derivative does. It tells us the slope at any point on this guy right here. Well, we want to know when is that slope 0. So all we got to do is take the derivative of this equation and set it equal to 0, and that'll tell us where this guy's located and that guy's located. So let's take the derivative. 3 comes down. Now when you drop the 3 down here, you're going to have 3 times a third. You notice that a third of 3 is just 1. It's gone. That gives you x squared. Plus, the 2 comes down. 2 times 3 is 6. The exponent goes down 1. There we go. X squared plus 6x. Now, this equation tells you the slope at any point on this line right here, this 1/3 x third. Tells you the slope at any point on here. Well, you and I don't need to know the slope. We want to know when is this slope 0. When is this x squared plus 6x equal to 0? So let's solve it for x here then. Well, a lot of us are going to want our 0 over on that side. Helps us sort of see it better. So what we're going to do is we're going to factor out an x. And I'm left behind with x plus 6 equals 0. That means either this x is 0 or the x plus 6 is 0. Well, we can quickly see that that x is 0. What's going to make that 0 if x is negative 6? So all I got to do, I know this is occurring at 0 and this is occurring over here at negative 6. What's the height value? What's the y value? Well, to find the y value, all I'm going to do is plug 0 back into this equation. Because I know that I'm right here, in this case, at 0 and then some height. Well, how do I find the height? I just plug 0 back in here. 0 cubed times a third plus 3 times 0 squared. That just gives me 0. So I actually know this first guy is occurring right here at the origin. Now what about the next guy? What about when I plug negative 6 in here? Negative 6 cubed is negative 216 times 1/3 plus 3 times negative 6 squared and so forth. That should give us 30... Hold on a second. 120. That's going to be 36 right there. Yep, that's 36. So I know this guy is sitting at negative 636. Now, since I drew the graph for you, yes, I can sort of see this critical point is actually a minimum. This negative 636 is actually a maximum. Now we got one more critical point. Don't forget about the point of inflection. Okay, the point where that guy starts, he's going curved up and then he starts curving back down. Sort of where it flips its turning, I guess you could say. The way we do that is, hey, we take the derivative of the derivative, better known as the second derivative, and we do the same thing. We set it equal to 0. So if I take the second derivative, the 2 comes down, that gives me 2x. This is x to the first, the 1 comes down, that just gives me plus 6. Now I simply set it equal to 0 and solve. You can easily see x is negative a third. Subtract 6, subtract 6, you can get 2x is equal to negative 6, divide by 2, you have it. So my final point, which I do know, is the point of inflection. But again, didn't ask you that. I just simply said, hey, give me the point. So here's one of them, and let's figure this guy out. When I plug negative 3 in here, that's going to be negative 27. That's going to be negative 9. That's going to be 27. I'm going to get 18 here. So you're going to end up with 18. So there's your third critical point for this guy. You just got to simply take the derivative, set the derivative equal to 0, solve for x, plug that x value back into the original to find the height, to find the y value. Then take the second derivative, do the exact same thing, and boom, out will come your main critical points.